Desmos calculator up, scientific calculator up.
All right.
Okay, so what I see here is there's a cone. Okay, there's actually two of them, and then there's this the cylinder here. Hopefully you see that as well.
Yep.
Okay, so the surface area of the cylinder, normally you would include the circles on the end, but you don't in this particular problem. So it's just this outside, which is 2 pi r h. This time the h is actually this dimension here along what it's like sitting on, and the radius is 3.
Your computer's a little lagging. I can't really see some of the writing.
Okay, well, the issue may be on your end, actually. I'm showing all good here. Maybe check your connection there.
Oh yeah, it just notified me that my connection's unstable, so
Make sure you're connected to the home Wi-Fi and not like an Xfinity or a hotspot or something.
yep, I'm connected to my home Wi-Fi.
Okay, are you able to see my screen now?
Yes.
Okay, so the value of R is 3, the value of H is 8. You follow that?
Yeah, are you moving your mouse at all? Because my
No.
looks like my oh, okay. Oh, there it is. Now it's not showing. Okay.
If you continue to have problems, I'm going to suggest that you disconnect and reset some things there, and then reconnect with me.
Okay.
So the cone, the surface area of the cone, it too also includes this circle, but see how it's covered up, so we don't need that this time. So the surface area is actually just pi r l, and L is new. L is actually what's called the slant height here.
Mhm.
So it's pi times the radius, which is 3 times 5. So you have to just add these together, but on the cone, you have 2 of them.
All right.
So go ahead and enter that into the calculator there. Actually, I take that back. They want it in terms of pi. So we need to do 2 times 3 times 8. That's 48 pi. And then 3 times 5 times 2, that's 30. So you
Right.
add these together and you get 78 pi.
Yeah, Mike. Yeah, I'm having a hard
Go ahead
time.
and disconnect. Go ahead and disconnect and just reset some things there and just connect back with me, okay?
Okay. Hello.
Hey, Christopher,
Hey.
are you able to see my screen?
Yes.
All right, let's try again. Hopefully there's no more issues. It's always always a fun one when we got stuff going on here. So let's look at
So
okay,
are
so
you
let's
writing something or are you
no,
just
no,
okay?
I'm scanning the questions here. I'll snip one in. So
Okay.
all right, so next question here we're going to look at, it says identify the lateral area and surface area of a cone. Cone is the party hat or the cone of shame, as you know. It's got a radius of 7 and a slant height of 15. Okay, so slant height is this one along the edge here. So the lateral area is pi RL. Okay, and L is this slant height here. So that's pi times 7 times 15. Could you give me that number rounded to 1 decimal place?
Sure. I get 329.9.
Okay, very good. So the surface area, if you remember before, it's the lateral area plus, or it's always like this thing we just found plus a little more. In this case, it's pi r squared, because you got the bottom, that's a circle. So you don't need to recalculate this part in your calculator. You just add to it pi 7 squared.
I get 483.8.
Yes, and do you see that the surface area is always greater than the lateral area because it adds a little piece to it?
Yes.
Good. Okay, let's look at another question here. I'm trying to do these in a specific order that makes sense. Doesn't always make sense, but let's do that. So here we go. Remember we were talking about those K values?
I believe so. It wasn't it K and then K squared and then K cubed.
So K squared is what you use for area.
Mhm.
So here's the K value here. They say the radius and the slant height are both multiplied by 1/2. So your K is 1/2. So what is K squared?
So square that.
I'm asking you, what is 1/2 squared?
Oh, it's 25 or 1/4.
1/4, not 25, 1/4. Good. Okay, next one. And this would be actually really cool to do if we had some paper. And you can actually do this with a tortilla. If you had a broken tortilla, where you had this like little piece cut out of it.
Mhm.
Okay. So they're saying like, imagine that this folds up into a cone. I don't know if you can visualize that or not.
Yeah.
You can. Oh, good, good. And by the way, this is the Pac-Man kind
Yeah,
of.
that's what I was thinking.
So the Pac-Man, folded, it becomes a cone. All right, so
Is that a
the
superpower?
that's a good joke. I may have to use that one for a certain someone. All right, so the diameter is this all the way across, and it ends up being the same as this right here. So the diameter is 12.
Well, that was really simple.
Yes. All right, so the next questions here are actually we'll move to pyramids
first.
Okay, so it says identify the lateral area and surface area of a regular triangular pyramid with base edge 10 feet. So these are really tough to draw, but I'm going to do my best to try to like draw it here.
Oh
So
yeah,
there's,
those kinds of pyramids. Yeah, those are tough to draw.
yeah, so there's basically a base, which is a triangle. Okay,
Mhm.
that's this one down here, and it says the base edge of 10, and it's 10, 10, 10. What kind of triangle has all the edges the same length?
That would be equilateral
Equilateral
triangle.
triangle. Yes. Yes. And then um
Slant height.
well, the front face is the same as the three side faces. You have three of these. Let me put that over here. Okay. And the base is 10, and like you said, the slant height is 14.
Mhm.
Okay. So now to find the lateral area, we have to first find the area of this triangle here.
Mhm.
Okay.
So I have a question.
Yes.
So when it says a triangular pyramid, I know pyramids have 4 triangles. Are they just saying that, oh yeah, this pyramid only has 3 triangles?
They're saying the base is a triangle. So what you're
Oh,
thinking of is a square pyramid. So a square pyramid base is a square.
hmm,
This is the ones you're used to seeing in uh, in school books and stuff like that.
yeah.
Its base is a square,
Okay.
and the sides come up at an angle. But in truth, like it's not that it's exactly smooth. They sometimes like have to tear the rocks to get them up on there.
Yeah.
Okay, so back to we have to find the area of this triangle. Okay.
Mhm.
And the other side is 14 as well. So if I draw a altitude, okay, you get the following triangle. You get 5 and 14.
Hmm.
And then the height here, the height is the square root of 14 squared minus 25. So the height is 196 minus 25. So it's the square root of 171. Okay, so the height is the square root of 171. So your lateral area is one of these triangles, and the area of a triangle is 1/2 base. The base is 10. The height is the square root of 171, but you have 3 of them. Okay, so could you go ahead and calculate that for me, please?
Sure. I get 196.4. I mean, 0.2, sorry.
Maybe I made a mistake here. 14 squared is what is 14 squared? Let me just make sure got this down. 14 squared minus 20.
196
Yes, that's right. Let me just double check you here. Not
is
saying anything wrong, but my numbers don't match with yours. Okay, the base times height. We got 3 of them. Ooh, that's really interesting.
is it supposed to be smaller?
No, it works out nicely. So let me do it another way. So there's another formula they use. Oh, you know what? I gave you the wrong. I'm sorry. I see the problem now. 14 is the height. So when they say slant height, they're referring to like let me draw it in red here so maybe you can see it. They're referring to like this line that goes down the actual face of the triangle.
Ah,
So it ends up being this right here, and that's what's 14. And that's what makes your area calculation a lot easier. So this is not the square root of 71, it is 14. Let's go ahead and retry that. Let's get the correct value there.
I get 210.
Yeah, get 210. All right, so you already mentioned that so the surface area is the lateral area plus the other part. In this case, it's 210 plus the area of an equilateral triangle. Okay, and I'm just going to look that up for us because I want us to just, yeah, so it's the square root of 3/4 times the leg squared, and I believe the leg is 10.
Okay.
So go ahead and give that calculation, get that calculation, and it's very heavy on formulas, this
So 296.6.
all right, perfect. Okay, let's see here. So you were asking about this. We're going to do a square pyramid now. And I see now that they're actually trying to make this calculation easier than doing all the stuff with triangles that I didn't realize. So this is a square pyramid.
Mhm.
Like this. And what I do is I like to draw this kind of going straight up, and then you connect these like that. So they say that the base edge is 11 and the slant height is 15. So on one of those faces, okay, this is 11 and then the height is what's 15. That's what's meant by the slant height. It's like if you could take a point from here all the way up to the top, that kind of like,
Yeah, it's in the middle, but it's also but since it's a pyramid, it's just slanted.
yes, good. So the lateral area is the area of one of the triangles, 1/2 base times height. But this time, how many triangles are there?
There are 4 triangles.
All right. So go ahead and calculate that.
.330.
Okay. And that's centimeters squared. Now the surface area, it's 330 plus, okay, it's the area of the base. The area of a base is a square.
.451.
Yes, that's what I got also. All right, fantastic. So last problem, maybe. No, I think that's it. We did it all. All right, let's move on to another lesson. I think it's like the same thing again. It's what is going on here? Oh, wow, this is weird. So I must have even used bad formulas, but we're going to move on. We need to keep getting through this. The second time that's happened. Okay, so this one hopefully is much more straightforward. It's volumes of prisms and cylinders. Let's start out with, I guess, probably the most straightforward type of question, which is, what is the volume of a cube? All right, so the volume of a cube, and there are formulas for this. Volume of a cube is length times width times height. So what is that?
Okay. times W times H. 729.
729, and then it's meters cubed this time. All right, so the next problems, you remember we were using that calculator the other day for finding the area of a regular polygon?
That's right.
We're going to need that again. So this is a pentagonal prism. It's a pentagon like this, but then it's extended. Okay.
Okay.
So we need to find, so the volume more generally is the area of the base, and this is the base over here, times the height. So your base edge is 5, and your height though is 9. So you want to go find that calculator where you get the area of the base, and there's many options, but you know, find one.
I have the calculator.
Okay, so you're gonna choose Pentagon.
Mhm.
You're gonna enter the base, and it'll give you some number, but then you have to multiply that by 9.
Okay. And what do you want the side?
I want the area.
You want the area, okay. 43.0.
Okay, that's fine, but that's not the final answer. I really want the volume. The volume is the area of that base times the height.
$387.
Okay, very good. So this one is similar. We don't, well, actually, let's do the other one because the other one we will need the calculator for. So this is a pentagonal prism. So it's another pentagonal prism. Interesting. Okay. So, you know, there you go again. You got the Pentagon, 9, 9, 9, 9, 9, but then it's extended or protruded. $13. So the volume is the area of the base times the height. The height is 13. You've got to find the area of the base.
Okay. $1,812.2 is my
that
final answer.
Yeah, that's your final answer for everything?
Yes.
All right, got it. Okay. So the next one here is a hexagon. So the base could be many things. We've done a pentagon. Now we're doing a hexagon. Okay, so here's your hexagon. Like that. 12, 12, 12, 12, 12, 12, right? Regular means they all have the same there. And then the height is the amount that you're extending it. And this time that's 10. So the volume is the area of the base times the height. The height in this case is 10.
$3,741 is my final answer.
Good, excellent. All right, so the next one we do not need the calculator for. We actually can just draw this and work it out by hand. It's a more standard prism. It's the block problem. Almost everyone plays with blocks growing up, and this one's got a rectangular face. That's 14, 3.4, and then it's extended. It's extended 11.6. So the height is generally like the extended amount. Okay. So when you've got just three sides like this, the volume is length times width times height. So go ahead and grab your calculator and work it out here.
552.2.
Good. All right, so we're moving through this relatively quickly. So the last problem is a little more difficult. It is so they're giving you an aquarium. So the aquarium looks like this, not to scale. They don't say it's a rectangular prism, but they give you 40, 36, and 26 as your dimensions.
Mhm.
And it actually doesn't matter where you put them in truth. So go ahead and find the volume for me, please.
Okay. 37,440.
Like this.
Yes.
Okay, so this is now it becomes a unit conversions problem. So they tell you that 1 gallon of water is 0.134 feet cubed.
Mm,
I think we've done problems like this where you've seen the units cancel.
yes.
Okay, and then they furthermore say, okay, the density of water is about 8.33 pounds per 1 gallon. See how the gallons cancel and you're left with pounds.
Yes.
So the when you're doing a unit conversion like you're doing here, you multiply the top numbers, okay, and then you divide by each of the bottom numbers. But because you have a scientific calculator, it allows you to enter this calculation. You'd want to enter something like this, and it will take care of the order of operations for you.
Okay, I get 2,327,426.9.
Perfect. All right. It's amazing how much faster this lesson went than the previous one. Sometimes, you know, they're very straightforward and we can just knock it out. Right. Do you want to do another 10 minutes here? I think we can get through another lesson.
Sure.
All right. Okay, the length, width are multiplied by 2/3. So that's your K value.
Mm.
So for like perimeter, you just use K. For area, you need K squared, and for volume, you need K cubed. So which one is this asking about?
K cubed.
K cubed. So figure that out for me. What is 2/3 cubed? Do not use a calculator. You need to do that by hand. You're cubing the top and you're cubing the bottom.
So
So basically I'm asking you, what is 2 times 2 times 2 divided by
that's
3
8.
times 3 times divided by
So
3
8.
times 3 times 3.
8/27.
That's it.
Okay.
Okay, next problem here, it's very much the same. So I want you to read this and tell me what is the K value.
The K value
And if I
is
haven't made it
2.
clear, is 2. Yeah, it's whatever is happening to the sides. And are we asking about area, volume, or perimeter?
Volume.
So what is K cubed?
8.
All right. Okay, so next question here. So a cylinder has a diameter of 22 centimeters. So the diameter is this distance all the way across, okay, and a height of 9. But that base there is a circle, okay? So what is the radius of that circle on the bottom?
Radius is 11.
Is 11. So the volume of a cylinder is pi r squared h. What is your r?
My R is 11.
And what is your h?
My H is 9.
Good. Go ahead and calculate that. Round to the nearest tenth, please.
I get 3,421.2.
Great. Perfect. All right. So the next problem here, it's another cylinder problem. It's not the same as the last one though. They rarely give you two of the same here.
All right. Could you give me 1 minute?
Sure.
Okay. Okay, I'm back.
All right, sounds good. So the cylinder again, it has a circular base. Okay, and the base of a cylinder is a circle. The area of a circle is pi r squared, which equals 64 pi. So we want to solve this for r.
Okay.
So see how if you divide by pi
Those cancel out.
and r squared equals 64. So what is r?
You get 8.
R is 8. So there's the radius. Now it says the height is equal to twice the radius. So how big is the height?
It's going to be 16.
Okay. And the volume of a cylinder is pi r squared h. I'd like you to calculate that for me with the given information now.
$3,216.99. Oh, so 3,217.
Yes. All right, very good. So the next problem is a composite shape.
Mhm.
And it's a little wonky because whenever you're trying to view something that's three-dimensional and two-dimensional space, it doesn't work. But this is the volume of a block. The block is the darker gray one minus the volume of a cylinder. So how do you find the volume of a block?
Length times width times height. So that's 729.
That's good. You remember that from what we did earlier. Volume of a cylinder is pi r
R
squared
squared
h. What's the radius?
The radius is 3
The height
and
is
9.
perfect. So round to 1 decimal place, please.
It's 474.5. That's my final answer.
Very good. All right, this is our last question. It's another composite figure. It's like the stick of butter, and then someone cut out a middle portion.
Yeah.
which is really frustrating, but people do that. Or like, remember, if you ever bake brownies, sometimes you
Cut it
cut
part of it.
out, and you're like, I really didn't want that. So you need the volume of the larger, I don't know, let's say larger block minus the volume of the smaller block. So the larger one is this 9 times 8 times 3. Hopefully
Okay.
you see that it's those there.
So would
And
that
then,
be 3 times 3 times 3?
yes,
Okay.
I think these are much easier to do because they're visual and you can see the part that's being taken away or added to.
$189 is my final answer.
Very good. All right, so all right, so I keep forgetting to mention this to you, but I want to, and we're not going to do any more problems today. I just want to show you something that I thought would be much more helpful here. So when you start a lesson, at the top of the lesson,
Mhm.
there's this printer icon.
Yeah.
I think it'd be a great idea for you to start printing out the lesson that you're working on.
Okay.
And I'll explain why next time I see you. So, all right. Well, that takes us to the end of our lesson today, Chris. Thanks so much for scheduling.
Okay.
Did a great job today. I'll send you notes in the screen recording here shortly, and I'll see you next time.
Okay.